And welcome to Houstonic.live. This is a live recording being done on 6:49 p.m., starting on the evening of Monday, May 12th, 2025. This is the 280 series. This is episode 280.c, or if you are more comfortable in decimal, 280.12. This episode corresponds to Chapter 12, called The Future, in the book Germs, Biological Weapons in America's Secret War by Judith Miller, Stephen Engelberg, and William Broad. This book was published, as we've said in every other episode in this series, September 7th, September 9th, 2001, actually just a couple dozen hours before the events of September 11th in the year 2001.
Conclusion. Is the threat of germs...
Oh my goodness, they skipped over the whole chapter. Holy moly, the whole chapter they cut. Wow. That means I got a lot of work to do. I gotta say it one more time. The whole stankin' chapter is cut from the audiobook. Well, then you know it's going to be good. I mean, as you can see, the page that I highlighted last night on episode 280.h. Chapter 12, The Future. In the spring of 2000, George Tenet, the director of Central Intelligence, met with some of the country's leading experts on biodefense, scientists, federal officials, health experts, and drug company executives. The group, known as the Non-Proliferation Advisory Panel, had been set up to give Tenet and his senior aides strategic advice. A former Senate staffer known for his blunt manner and creative use of expletives in private conversations, George Tenet had been pushing his agency to do more to counter the threat of germ weapons. Early in his career, he had focused on nuclear arms control and how to monitor an adversary's missiles and warheads. Now he was confronting a problem that was far more complex, and he wanted help. He told the panel that its suggestions were mundane. The CIA, he said, was looking for bold, imaginative solutions, something that would, quote, break the back, unquote, of biological terrorism. The Soviet scientist who worried Andy Weber figured prominently in George Tenet's view of the threat. A few weeks earlier, he had warned Congress that a growing number of nations were trying to import the talent needed to make dramatic leaps in producing biological agents and delivery systems. George Tenet said, "They can buy the expertise that confers the advantage of technological surprise." Terrorists were also experimenting with germ weapons. Osama bin Laden, the Saudi exile, had been training his operatives to use chemical and biological toxins, George Tenet said. Although he did not say so in open session, the CIA and the Pentagon had been working separately for nearly 3 years on several highly classified projects to develop a better understanding of germ weapons and delivery systems developed by foreign scientists. The programs were among the government's most closely kept secrets, their code names known only to a handful of officials. Participants were required to sign special security forms in which they waived their right to resist an investigation of unauthorized disclosures. There were several reasons for the extraordinary secrecy. Some of the research focused on American vulnerabilities, and officials did not want terrorists or other nations to know which agents or techniques would work best against soldiers or civilians. Officials privately acknowledged another reason for their sensitivity. The projects were bringing America much closer to the limits set by the 1972 treaty banning biological weapons. Several federal officials had serious qualms about the research and had warned colleagues that a diplomatic disaster might ensue if the secret programs were revealed. The treaty was maddeningly vague, and government lawyers had spent years trying to translate its provisions into practical codes. Government experts agreed that the pact allowed a broad range of experiments with germs and toxins, as long as the aim was defensive and the quantities of agents small. Studies of weapons were more problematic. The treaty banned nations from developing, producing, acquiring, retaining, or stockpiling a weapon or other means of delivering germ agents for hostile purposes or an armed conflict. The government's legal experts had never formally wrestled with whether a country could buy, steal, or manufacture a germ bomb and use it to establish standards for testing vaccines or other defenses. Some experts believed such experiments were acceptable as long as they were not intended for war. Other government officials contended that a weapon was, by definition, meant to inflict harm and was therefore out of bounds, even for defensive studies. A bomb, they would say. America's biodefenders were wary of any work that came close to violating the treaty. Many had been in government in the late 1980s when Senator John Glenn's investigation and hearing prompted the much tighter limits on germ research. In the years that followed, scientists at Fort Detrick scrupulously confined their work to germs or toxins on the military's validated list of biological agents, a formal document negotiated among intelligence officials. Army researchers grumbled that the list was years out of date and did not include many of Russia's most lethal futuristic germs. The difficulties of intelligence made validating a threat extremely difficult, and Glenn's action was seen as imposing a stifling standard on defensive research. Even so, nobody wanted to risk more trouble with Congress. By the mid-1990s, Glenn had retired and the restrictions loosened a bit, but the Army lab at Fort Detrick was facing budget cuts and had little money to take advantage of the more flexible rules. It was a different story at the CIA, where agency officials were significantly expanding programs that tracked the spread of nuclear, chemical, and biological weapons. Iraq's statement to UNSCOM in 1995 that it had produced thousands of gallons of germ weapons came as no surprise to the CIA's analysts. They knew that Iraq had repeatedly tried to buy cluster bombs that might be turned into germ weapons. But Baghdad's admissions heightened the interest of senior policy makers, the customers as the agency calls them. Suddenly, many in Washington wanted to know more about biological weapons. The agency asked its spies to collect more information, as did the National Security Agency, which eavesdrops on the world's phone, fax, and email communications. Bill Patrick, who sometimes worked as a consultant for the agency, also felt the CIA could do a better job. For years, he argued, the nation's intelligence services had focused their efforts too narrowly, tracking mainly research and development of pathogens. Obtaining and culturing virulent germs was an important first step for an aspiring bio-warrior. But as Patrick had learned in the 1950s, that was only the beginning. Producing industrial quantities of dried pathogens of the appropriate size was an equally daunting challenge, as was figuring out how to make effective bombs, missiles, or aerosol devices. The CIA, Bill Patrick complained in a speech to Air Force officers, had long focused on agent. It was, as Bill Patrick said, all they looked at. Patrick argued that it was equally important to understand the inner workings of munitions and their delivery systems. If you can't deliver the most of the germs to a target, Patrick told the officers, you have not done your job. George Tenet, who had been the agency's number 2 official, was sworn in as director in July 1997, and he immediately told senior aides that he wanted to see even more attention paid to biodefense. Soon after, he appointed John A. Lauder, a veteran CIA official, as director of the agency's Non-Proliferation Panel, a group of analysts who tracked the spread of unconventional weapons. More specialists were hired, and the agency pulled together the panel of outside experts, persuading Thomas Monath, again, who became the boss of Robert Malone at Newling Corporation, the virologist who had been part of the experts' meeting with President Clinton in 1998, to serve as chairman. The new focus on biological weapons was a boon for analysts like Gene Johnson, a protege of Bill Patrick, who had been hired by the agency. Gene Johnson was a virologist who had worked for years at Fort Detrick and was a creative man, a doer, a scientist who had risked his life to hunt for Ebola's hiding place in Africa. He was the most vividly drawn characters in the book The Hot Zone, a book written by Richard Preston about the Ebola virus, though colleagues said he disliked the depiction. Richard Preston, the author of The Hot Zone, said, Gene Johnson is a large man, not to say massive, but with a broad, heavy face and loose, flying, disheveled brown hair and a busy brown beard and a gut that hangs over his belt, and glaring deep eyes. If Gene Johnson were to put on a black leather jacket, he could pass for a roadie with the Grateful Dead. Gene Johnson, who shared many of Bill Patrick's views on the importance of understanding munitions, began urging his colleagues to study the weapons systems developed by the Soviet Union to mount a biological attack. How were such bombs made? How well did they work? Could they be copied? A project took shape. CIA officials named it Clear Vision, an attempt to see into the future of biological warfare by understanding its past. Intelligence officials say the CIA's main goal was to improve the type and quality of the information it collected for the government. It also wanted to be able to better assess the intelligence it had previously gathered about foreign germ weapons and the credibility of the people and other sources that had provided it. The principal focus was on foreign weapons, and the analysis was to be hands-on. Gene Johnson had lots of ideas about enemy weapon systems that should be tested. He showed colleagues a blueprint of a biological warhead the agency might study. CIA officials believe that the work was well within the bounds of the Germ Treaty, allowed by the provisions that permit defensive research. Clear Vision was under orders to pursue projects only when American intelligence received specific, credible reports about a threat posed by a potential adversary. It was not a license to roam, to try out blue sky theories about what some evil scientist might do. Clear Vision zeroed in on the weapons systems the Soviets had developed. Unlike the Americans, the Russians had built long-range missiles to hurl germ warheads between continents and had begun to make cruise missiles that would fly below radar, operating at ideal speeds for dispensing lethal clouds. A few years earlier, Ken Alabek told Bill Patrick and CIA debriefers about Moscow's success in designing missiles and bombs. The two men later collaborated on a secret paper comparing the programs of their two countries. There were many questions. Some of the most significant centered on the miniature bombs, or bomblets in military parlance, that the Soviets had developed to spread germs. How did the bomblets fit into warheads? How and when were they scattered during an attack? How well did they work? The first-generation biobombs produced by the United States and Russia in the 1950s were crude devices. Liquid or dried agent poured or packed into a metal bomb filled with explosives. The blast and heat from detonation destroyed much of the biological agent. In his presentation to the Air Force officers, Bill Patrick said that only 1 or 2% of the anthrax in the early American bombs survived their detonation, which was, in his words, a travesty. Moscow and Washington had solved the problem over several decades, each in its own way. Americans had created bomblets and filled them with Freon for cooling. The Soviets had found a different way, Ken Alabek revealed, packing their bomblets into plastic pellets to soak up the explosion's heat and reduce the pressure on the germs. Gene Johnson was eager to analyze the properties of the Soviet bio-bomblet, and CIA headquarters directed American intelligence officers overseas to obtain one, perhaps in one of the former Soviet republics. The American teams sent out to Vozrozhdenia Island in 1997 and 1998 to sample the anthrax that the Soviets had buried there were also enlisted in the hunt. They were told that even a fragment of a bomblet would be useful, and eventually found one. Gene Johnson was delighted. The Clear Vision team's desire to analyze a Soviet-style bomblet was prompted by reports in the mid-1990s that more than one country was running tests on what appeared to be biological munitions. At about the same time, the agency also picked up indications that Iraq was trying to rebuild its germ program. Baghdad's attempts to make germ bombs in the late 1980s were no more efficient than comparable early efforts by the Soviet or Americans. But what if Iraq hired a Soviet scientist who knew how to make a bomblet? And if the Iraqis made such a bio-bomblet, how efficient would it be? A senior agency official who was debriefed on the program said, "We wanted to learn all we could about past weaponization and future weaponization that might be used against us. We wanted to go back to get the materials, the systems that had been used in the past, and use them to better understand what we were likely to face. Testing a bomb's dispersal characteristics would illuminate how it could be used against Americans in an attack. CIA officials believed the treaty permitted the testing of a fully operational weapon, but they chose not to. Intelligence officials said the devices manufactured at the orders of the Clear Vision team were not functional arms that could have been used on a battlefield. They lacked the explosive fuse needed to detonate a bomblet dropped from an aircraft, and they were filled with a simulant, not a live agent. There was some confusion, even in internal agency documents, about what was being done. Memos referred to a reverse engineering of a bomblet, a reference that the officials said was imprecise because the weapon was never completed. CIA lawyers reviewed the project and said it was consistent with the Germ Treaty. The agency went on ahead without asking the White House for approval. In early 1999, Gene Johnson embarked on a new attempt to obtain equipment used in the Soviet Germ program. The mission began when American officials found what appeared to be a bomblet filling machine outside a reinforced bunker that once held germs at Stepnogorsk in Kazakhstan. Intelligence analysts who looked at photos of the machine then showed it to Ken Alabak, who said he, too, thought it had been used to fill bomblets with agent. Gene Johnson, eager to see firsthand how the device functioned, assesses its capacity, and perhaps, at long last, secure traces of the Soviet super anthrax that Ken Alabak's plant had made, asked Pentagon officials to purchase the machine from the Kazakhs and ship it back to the United States. Although the CIA authorized up to $150,000 for the purchase, officials at Stepnogorsk, somewhat puzzled by the request and the secrecy surrounding it, agreed to sell the device for only $10,000. In the spring of 1999, according to informed foreign and former American officials, the machine was quietly shipped to the United States and subjected to numerous tests aimed at detecting residue of anthrax or any other pathogen. After weeks of testing, the results were in. The suspect bomb-filling machine had no traces of anthrax. Instead, analysis showed that the putative machine for filling germ bomblets was in fact designed to put caps on bottles. Officials at Stepnogorsk eventually solved the puzzle. When refrigeration units at Stepnogorsk's dairy plant had broken down in the late 1990s, Gennady Lepyoshkin, the germ plant's director, had invited the city's sole dairy manufacturer to move the machine into his bunker to continue producing milk for the city. The machine, and a dozen others just like it now standing idle in the neighboring dairy plant, had never been used to fill weapons, Kazakh officials insisted. They had processed milk bottles. A subsequent visit to the dairy plant and discussions with plant executives seemed to confirm this account. The CIA had spent $10,000 on a milk bottling machine. The verdict was by no means unanimous. Despite the lab tests, the interviews of Kazakh officials, and the visits to the dairy plant, some analysts remained convinced that the machine was not innocent. Ken Alabak, who had told the CIA that the machine was a bomblet filler, insisted in a subsequent interview that the machine was one of the many dual-use items in the Soviet germ program. The machine could fill containers with both powdered milk or, as at Stepnogorsk, powdered anthrax. He knew the machine well, he said. Earlier in his biowarfare career, he had been the director of the Soviet plant in Moscow that had built items like this. In mid-1999, the CIA described Clear Vision to the Non-Proliferation Advisory Panel, the agency's group of outside advisors. Gene Johnson passed around an aluminum replica of the bomblet. While the panel was generally supportive of the program, one advisor, Joshua Lederberg, was uneasy. Building any type of weapon, he told the CIA officials, skirted close to the Germ Treaty's prohibitions. He suggested a legal review. Wasn't this the sort of project, another panel member asked, that should be brought to the president for approval? Some of the experts questioned whether the intelligence gains from the program were worth the political risks. The agency's lawyers might well be right about the legal fine points. but the appearances might be devastating if the project were disclosed. The United States has championed the Germ Pact and signed dozens of other arms control treaties, albeit out of self-interest, not altruism. Such a controversy could undermine a host of global accords that, however imperfect, had probably constrained potential foes. For every objection, the agency had a counter-argument in favor of clear vision. For instance, the CIA noted that it was responsible for assuring the government that every joint research project with Russia, such as Andy Weber's at the Pentagon and those of the Energy and State Departments, did no damage to national security. CIA analysts needed to know the exact state of Russian research into germ munitions to assess whether the American expertise might help Moscow make better weapons. At about the same time, key administration officials learned about the clear vision work on Soviet bomblets. Lauder, the head of the agency's Non-Proliferation Center, mentioned the project to two National Security Council aides. Curious and somewhat concerned, they asked the agency for a more detailed briefing, colleagues recalled. Gene Johnson went to the White House to explain, equipped with charts and graphs. In early fall, he described the program to several National Security Council staffers. He said the CIA's lawyers believed it was consistent with the Germ Treaty. The White House officials were not entirely persuaded about the project's value, asking colleagues what exactly would be gained from producing a bomblet. They saw risks if the project were publicly revealed. Imagine what the United States would conclude if it discovered that, say, Iran had built and tested its own Soviet-style biological bomb. The White House asked the CIA to brief the State Department and the Pentagon about the program. The CIA said it was already doing so. James E. Baker, the White House lawyer who reviewed secret intelligence matters for the National Security Council, was asked by White House officials to conduct a separate scrub of clear vision to ensure it complied with America's treaty commitments. Jimmy Baker, who was on loan to the White House from the State Department, had a reputation for giving fast, meticulous, and fair-minded counsel. He concluded that clear vision, as described by the CIA, did not violate the treaty's ban on developing weapons, since it was meant to replicate foreign munitions and improve American defenses against a biological attack. A White House aide drafted a memo to Sandy Berger, the National Security Advisor, describing clear vision and outlining its goals. He was not asked to make a decision or give his approval. The CIA had not sought a White House blessing for clear vision, officials later stressed. The agency was simply informing the National Security Council of its plans. White House officials say that President Clinton was never even told of the program. With the tacit approval of a few White House officials, the project nonetheless moved forward. In the ensuing months, Battelle, a military contractor in Columbus, Ohio, with sophisticated laboratories, conducted at least 2 tests on a model of the biobomblet that measured, among other things, its dissemination characteristics and how it would perform in different atmospheric conditions. And we're going to look up Darrell Galloway. Darrell Galloway, who did a lot of work with the Defense Threat Reduction Agency. This is a picture of Darrell Galloway from the 2008 Defense Threat Reduction Agency, or DTRA, publication. Now, Darrell Galloway was in the United States Army as a medical corpsman and medical laboratory technician from February 1969 to December of 1971 in Virginia. He joined the United States Navy, where he was there for 26 years, from 1980 to June of 2006. And at that time, he actually became the Deputy Director of the Biodefense Research Director at the Navy Medical Research Center in Rockville, Maryland. And between 2003 and 2007, he was with the Defense Threat Reduction Agency. More specifically, I think more relevantly, he was at The Ohio State University, also 22 years, between 1984 and 2007 in Columbus, Ohio. And on July 2001, here he is as a co-author in the Journal of Infection and Immunity, titled Protection Against Anthrax Lethal Toxin Challenge by Genetic Immunization with a Plasmid Encoding the Lethal Factor Protein. This is basically a DNA vaccine for anthrax that encodes a toxic protein in DNA. And he's doing this work while at the Department of Microbiology at the Ohio State University. Now, on October 14th in 2001, Ohio State University News had an article titled, "New DNA-Based Vaccine Approach Protects Mice Against Anthrax." I want people to notice that if there was going to be a DNA vaccine positioned for anthrax, the most likely source of it, there are several companies. One was a company called VaxGen, VaxGen, but I think a little bit closer to what was being suggested as the ideal, almost contamination-less variant would have been through a company called Vical, Vical. Now, I want to stress that Vical was not directly testing or producing this product. It was, however, providing its technologies to Battelle and Ohio State University to be tested. And the person that was handling that was Daryl Galloway. In fact, this article from October 14th, 2001, and you could imagine that this was already in the queue, all right? This was already written. It's not like they just called them the day before and they ran the news article the next day. This stuff was well choreographed. This stuff was well choreographed at the timing that this book, Germs, was written. This stuff was well choreographed before the date and before the events of September 11th, 2001. And at the bottom of the article, it says, in a recent yet unpublished study, the Ohio State research team, in collaboration with scientists from Battelle, has demonstrated that a vaccine can protect against a significant aerosol challenge for more than a year following the last inoculation. Galloway. Now remember, Daryl Galloway creates a company called Daryl Galloway Associates, which then hires as a business director or something like that, Robert Malone. So this is yet another potential Robert Malone connection in the book. As we've also have shown in that October 29th, 2001 article that Los Angeles Times ran called "Vaccinations Problematic," where they review the old anthrax vaccine against the new anthrax vaccine. Again, it's side by side. Meryl Nass saying the old anthrax vaccine is problematic. She won't get one. And Daryl Galloway, the microbiologist at Ohio State University, but more importantly, doing work with that's being funded in part by Battelle or in collaboration with Battelle, is effectively, I believe, if he's using products and technologies from Vical, he's working with Robert Malone or doing some type of counsel with Robert Malone. This would suggest that Robert Malone and Meryl Nass are in some way side by side since before September 11th, 2001 regarding the anthrax vaccine. And also mentioned in this article is Thomas Monath. And Thomas Monath was just mentioned 2 pages ago in the book. In the ensuing months, Battelle, a military contractor in Columbus, Ohio, with sophisticated laboratories, conducted at least 2 sets of tests on a model of the bio-bomblet that measured, among other things, its dissemination characteristics and how it would perform in different atmospheric conditions. A series of experiments in a wind tunnel revealed how such bomblets, after release from a warhead, would fall through the air over targets. By the middle of the year 2000, the tests were complete and the effort pronounced a success. At about the same time, a new round of questions from other parts of the government arose about whether Clear Vision complied with the Germ Treaty. The CIA had briefed the Congressional Intelligence Committees as well as other branches of government. The program had become controversial, one senior intelligence official acknowledged, because it was pressing how far you go before you do something illegal or immoral. The CIA's Deputy Director, John A. Gordon, called for an interagency review. A broader group of lawyers that included officials from the Pentagon and State Department and Justice Department was introduced to Clear Vision. The meetings dragged on for months. The State Department representative argued that the treaty ruled out any tests involving weapons. The CIA did not back down. Projects like Clear Vision, the agency argued, were a response to specific intelligence about a possible adversary. Hence, they were defensive and clearly permitted by the treaty. The debate ended without any resolution. agency officials continued to assert that the treaty gave them the right to build and test germ munitions for defensive purposes. Nevertheless, the senior officials subsequently took a pass on some of Gene Johnson's more aggressive proposals. One official recalled asking, "Did we really need rockets?" In the wake of controversy over clear vision, the agency's leadership also encouraged the CIA's biodefense specialists to expand their efforts beyond the Soviet legacy. The agency needed to understand what a low-tech terrorist could accomplish. "What could you do with a suitcase?" "What could you do with a vial?" the official said, recalling his questions to the agency's germ experts. Although Clear Vision had initially focused on Soviet weapons, intelligence officials said its planners recognized from the start that they would have to address the military implications of gene splicing, a view reinforced by reports of such research abroad. Scientists working at the agency's direction took the first steps to create a superbug. Intelligence officials said this work included a number of genetic manipulations to identify genes that could be moved into pathogens to make them more deadly. But that work was halted. Intelligence officials said no target gene was ever moved into a pathogen. Even so, intelligence officials said, the agency's lawyers remained convinced that the germ treaty allowed such research. Whether or not Clear Vision provided the invaluable insights that its champions asserted it would, the effort itself fizzled. By early year 2001, it was evident that the CIA had lost its taste for research that edged close to the treaty's limits, although some at the agency continued to defend the project's value. Nevertheless, the program was out of money, and the agency's leadership did not press for new appropriations. Gene Johnson, who had been the deputy director of the CIA's biological group, left his management post to become a senior scientist for germ defense. The panel of outside experts set up to guide the agency's thinking on the biological threat quietly stopped meeting. Clear Vision's recombinant work was put on hold. As the word of the secret research spread within the close-knit community of scientists who advised the government on arms control issues, some raised strong objections to the CIA's rationale. Barbara Hatch Rosenberg, who had discussed the germ warfare ban with President Clinton, insisted that the treaty did not let nations make bombs or any other kind of biological weapons. Narrators note, as a reminder, Barbara Hatch Rosenberg was openly suggesting, as of late October or November of 2001, that the most likely source of the anthrax letters or people involved in sending the anthrax letters was someone within the United States government, and she was very clear that it could have been someone within USAMRIID or the U.S. Army. Yet again, all of the most important people who drove the post-9/11 narrative, post-anthrax letter narrative, are also in this book. And, oh, by the way, the person that wound up being put on stage, accepting to be put on stage, I suspect, as a main suspect of those letter sending in the summer of 2002, was none other than Stephen Hatfield, who is now currently a special assistant of sorts to HHS Director Robert F. Kennedy Jr. Continuing on. As word of the secret research spread within the close-knit community of scientists who advised the government on arms control issues, some raised strong objections to the CIA's rationale. Barbara Hatch Rosenberg, who had discussed the germ warfare ban with President Clinton, insisted that the treaty did not let nations make bombs or any other kind of biological weapon. She was amazed that the government had even debated the point. Although scholars had exhaustively dissected the treaty, Barbara Rosenberg said she knew of none who had ever advanced this interpretation of the global accord. Moreover, she said, the research was unnecessary. Whether a bomblet emitted 5 or 50% of its deadly cargo was ultimately irrelevant if the germs were sufficiently potent. In terms of threat assessment and defense spending, the American military had to assume the worst. The Pentagon had its own tangle of ambitious, sometimes overlapping secret programs to develop defenses against biological and other unconventional weapons. They had exotic code names, like Bite Size, Black Star, and Druid Tempest, to name but a few, and several aims. Some gathered intelligence to help analysts assess the emerging biological threat. Others were searching for new ways to destroy an adversary's biological program without unleashing an epidemic. Since the mid-1990s, the Pentagon had been burying components of germ and chemical facilities in the hardened underground tunnels at the government's Nevada test site to see whether the Army's munitions and bunker-busting bombs could destroy them. The research had its origins in the Gulf War, when Schwarzkopf and Powell agonized over whether an attack on Iraq might kill tens of thousands of civilians or Allied troops. In 1998, the Pentagon began an ambitious venture to see if it could actually build a factory capable of making germ weapons with commercially available materials. The work was commissioned by the Defense Threat Reduction Agency, DTRA, known as DTRA by its 2,000 employees, was a new fiefdom in the United States Defense Department, created in 1998 through the merger of several Pentagon offices that had worked separately on proliferation issues. Narrators note it also includes components of weapons of mass destruction and nuclear disarmament that came out of or were within the United States State Department. Continuing on, the project was codenamed Bacchus, that's Bacchus, which is an inside joke, one that scientists would appreciate. Bacchus was the god of fermentation, often an essential step in making a biological weapon. DTRA officials, or DTRA officials, planned to bury the equipment in the United States and overseas and then set up a working germ factory that would make harmless bacteria to simulate the manufacture of large quantities of anthrax. The agency's director, J.C. Davis, said Project Bacchus was looking for what intelligence agencies generally call signatures, or telltale clues of hidden things or activities. In this case, the hunt was found for distinctive patterns of equipment buying. A signature of a nuclear bomb program, for example, might be widespread purchases of uranium. J.C. Davis, a physicist with Lawrence Livermore's National Laboratory, who was DTRA's director until June of 2001, said Bacchus posted several questions, such as, "Can I find a small biosystem being put together? Can you see the signatures? And can I characterize it well enough to attack it?" Pentagon lawyers reviewed the project and ruled that it was permitted by the treaty. No biological agent was being produced, and the purpose was clearly defensive. In May of 1999, armed with $1.6 million in funding and commercial catalogs of lab equipment, a small team of DTRA employees quietly began buying new and second-hand equipment to build a small-scale germ facility at the Nevada test site. Within weeks, officials had acquired almost everything it needed. From a Lowe's hardware store, they had purchased pipes and filters to clean contaminated air. It took about 2 months more to find the most crucial piece of the equipment, a fermenter in which to culture and grow the germs. A 50-liter unit was acquired from a supplier in Europe, DTRA officials said. A company in the Midwest sold the team an off-the-shelf milling machine for grinding down clusters of dried germs to the best size for human infection. By the summer of year 2000, the team had built a functioning facility that had turned out 2 pounds of product, or anthrax simulants, in test runs. The low-tech plant produced Bacillus thuringiensis, which is the biopesticide Iraq made at Al-Hakam after the Gulf War, and Bacillus globigii, which is an innocuous bacterium long used to simulate anthrax. The dried particles, white and taupe-colored, were 1 to 5 microns wide, the ideal size for germ weapons. If anthrax spores had been dropped into fermenters, the United States could have made enough biological agent to mount a deadly attack. The project had proven its point. A nation or bioterrorist with the requisite expertise could easily assemble an anthrax factory from off-the-shelf materials. DTRA officials say the overseas purchases were not detected. The results suggested that with precious little money and off-the-shelf equipment, a state or even a group of terrorists could build and operate a small-scale germ weapons plant, probably without the intelligence officials' knowledge. J.C. Davis said, "That's one of the reasons why it was a useful exercise." Narrators note, "Isn't it convenient that it was proven that a few terrorists, if you will, could have on their own, with nothing more than supplies from Lowe's, produced all the anthrax needed to perform a large-scale biological terror attack on a major U.S. metropolitan center?" In the late spring of 2001, DTRA found yet another use for the production plant when a squad of military commandos attacked it in a mock raid. The mission was to neutralize the plant, to disable the fermenter and milling machine without spreading any germs. The operation was codenamed Divine Junker, and the raid was deemed a success. Project Bacchus and the other related research was approved by a Defense Department panel set up to make sure such operations complied with arms control treaties. But few officials outside the Pentagon, and apparently even within the department, knew much about the project at all. A spokesman for the defense agency said DTRA did not know whether Secretary Cohen or any other senior Pentagon official had blessed Bacchus or even been told of it. The only person in Congress apparently informed was not a senator or a congressman, but a staff aide on the House Government Affairs Committee. Senior National Security Council staff aides and several White House officials claimed to never have even heard of it, meaning never heard of Project Bacchus. Moreover, there does not appear to have been anyone in government keeping an eye on the full range of secret projects underway to improve biodefenses. Other than, of course, the people writing this book that everyone's going to be able to read in the fall of 2001. If the White House had known that the United States had both built a factory capable of making germ agent and tested a biobomblet, it would have demanded a much broader legal review, one official said. But senior Clinton officials had been briefed only on clear vision, what a top official called one part of the iceberg that threatened to collide with the germ treaty. White House officials say that neither President Clinton nor his senior aides ever reviewed the full package of ongoing efforts. Was it really wise for the United States to go ahead with both weapons experiments and a factory capable of producing large quantities of biological agent? The issue was never joined at the highest levels. Secretive efforts such as Bacchus and Clear Vision were unfolding at a diplomatically delicate moment. After years of argument, the world's nations were finally moving closer to adding some means of enforcing the Biological Weapons Convention. New language was being drafted in a protocol to the treaty that would require nations to list laboratories in which they were doing advanced research and submit to independent inspections. The effort to draft the protocol had the strong support of Eliza Harris, a mid-level National Security Council official, but it was opposed by virtually every other agency. The Commerce Department disliked the draft, fearing it would expose America's pharmaceutical manufacturers to intrusive, unnecessary inspections in which valuable trade secrets could be lost. National security officials felt the treaty would be impossible to verify, even with the new language. Rogue nations would still cheat, but the new treaty provisions might force the United States to list some of its secret defensive research on germ weapons. For instance, the draft protocol would have required Clear Vision's planned recombinant work to be openly declared. The text, written by a Hungarian diplomat named Tibor Toth, last name Toth, called for countries to disclose any arranging and manipulating nucleic acids, organisms, and microorganisms to produce novel molecules or to add to them new characteristics. Officials felt there was serious concern about how an inspection regime proposed in the protocol would even work. At Congress's insistence, the administration officials had established teams of mock inspectors who, between 1994 and 1996, walked through several American commercial laboratories, vaccine production plants, and university and medical school labs whose research was undeniably defensive. The results were dismaying to supporters of a treaty protocol. Even innocuous experiments looked as if they were part of a germ program when seen with a jaundiced eye. The visits that were aimed at reducing doubts about the treaty had only served to deepen them. Undaunted, Eliza Harris continued to fight for the new protocol. But the agencies resisted. The result was gridlock. In mid-2001, after a review that involved all the relevant government agencies, the Bush administration announced its opposition to the protocol. The proposed agreement, it said, was overly intrusive and unlikely to deter cheaters. Most every other country, even Washington's closest allies, Britain and Japan, immediately criticized the move, voicing support for the draft protocol. As the world's nations quarreled over how to improve the treaty, the new biology was racing ahead. The audacious work done by the Soviets, the details of which were continuing to emerge, was seen as a sign or a warning that something, especially something momentous or calamitous, is likely to happen. American officials knew that the Russians had pressed well beyond the Pentagon's experimentation in the 1980s with recombinant germs, producing lethal weapons from designer bugs. As American officials pondered what the future might look like, they often found themselves focusing on men like Sergei Popov, who had moved biological warfare to the edges of modern science and beyond. Sergei Popov, that's P-O-P-O-V, had defected to Britain in 1992 after the collapse of the Soviet Union and had then moved to Dallas, in the United States. Now, in early year 2001, he was working for Advanced Biosystems Incorporated, a company outside Washington, D.C. Some narrator's notes. And I copied a timeline from another website. I haven't validated all the information in the timeline, but I copied it because some things in there I was able to validate and I found it useful. The source is listed in there. This is copied into the Houstonic research page I have for Jerome Hauer. It says, on October 2nd, 2001, 2 days before the first anthrax case was reported in Boca Raton, Florida, and a week and a half before the first anthrax was sent through the mail to NBC News in New York City, Advanced Biosystems received an $800,000 grant from the National Institutes of Health to focus on very specific defenses against anthrax. Remember that Howard joined the NIH on September 10, 2001 as an advisor on national security. This data point here shows or suggests that Advanced Biosystems is cashing in and receiving an $800,000 grant, and maybe it's because of some inside knowledge they have of the anthrax letters. I'll research more into this company at another time. The more I've researched, the more I see data like this different. If Advanced Biosystems really wanted to make a whole lot of money or something like that by having an anthrax attack, well, first off, they would have gotten the money, hopefully, long beforehand. And it's really hard to believe that an anthrax attack would happen so one company could get an $800,000 grant. Even $1 billion wouldn't even be close to enough to pay off everyone you would need to. And even if you could, you couldn't pay everyone off. You could not pay off everybody in the world to get away with it. Now, if no one cared and you only had to pay off a couple of people, that would be one thing. But you would have to pay off or compromise tens of thousands of people collectively. It's impossible. So to think that $800,000 is the reason why this all happened. And I would actually see this as the opposite. This would mean that someone said, approve the $800,000 grant just before the anthrax letter to make sure that there's some stupid data point to suggest that Advanced Biosystems should be looked at. So I actually see it as just the opposite. I see this as someone desperately trying to lay a trail of breadcrumbs. Sergei Popov had defected to Britain in 1992 after the collapse of the Soviet Union. And later on, Sergei Popov moved to Dallas, Texas, in the United States. Now, in early year 2001, Sergei Popov was working for Advanced Biosystems Incorporated, a new company outside Washington, D.C. Ken Alabak was its president, and the company was a sponge for former Soviet weapons scientists, as well as federal research dollars. The aim was to use weapons skills for peaceful ends by doing research on germ defenses. The work was helping Popov think and talk about what he had done before. He went on to say, "For 8 years I tried to forget, but it's very difficult to get rid of the past and become a completely new person." Ken Alabek had described Sergei Popov's work and Moscow's vast program to develop recombinant arms and intelligence debriefings in his 1999 book titled Biohazard. But there were grumblings that Ken Alabek, a manager, had moved beyond his personal knowledge. There were no such doubts about Sergei Popov. He had lived in the future. Hardly anyone in the world had done more with the new biology to create weapons. It went far beyond the traditional ways of trying to hurt and kill. Sergei Popov and his colleagues built germs meant to seize control of the human metabolism, causing a body to self-destruct. Sergei Popov earned his doctorate in biochemistry in 1976, just as the recombinant revolution was getting underway. He was snapped up by Lev Sandakchiev, the Soviet biochemist, then in the process of founding Vector, the secret center for research on viral warfare that Andy Weber had visited. Andy Weber, who, later on, was of the DTRA. Vector had a few dozen people when Sergei Popov arrived. It would eventually employ more than 4,000 people. Sergei Popov said that in the late 1970s, he and his Vector colleagues began synthesizing whole genes that expressed such substances as endorphins, the pain-killing hormones that produce feelings of euphoria when lovers kiss or runners push themselves hard. The goal was bliss overload. By creating design bugs that oozed endorphins, the Soviet scientists hoped to trigger an overdose that resulted in a coma and perhaps even death. But the plan failed. The scientists spliced these synthesized genes into viruses and then infected lab animals with the modified bugs. But there were no deadly repercussions. Sergei Popov and his colleagues regrouped in the early 1980s as the Reagan administration was entering office. One team continued on the same path and, after much work, found what Popov described as the best places to insert foreign genes into viral genomes, ensuring good expression of lethal effects. How much closer to mRNA and DNA vaccines can you possibly get? They're talking about creating agents that will result in creating proteins, expressing proteins. I also want you to note, does this say specifically human cells? Does it say there that the viruses which are created will somehow only impact human cells? Because it would be very easy for what they're to be doing here was to actually be creating a bacteriophage. A phage which can access bacteria which lives either in someone's skin or respiratory system or even, and it lives in there in great abundance, the gut biome. You can make a phage which can then cause the bacteria that exists within one's own respiratory system or gut biome to then express whatever toxins you want. In fact, the bacterium that exists within the airways in the gut biome are immensely more accessible than the cells of a human body itself. And even if one were to manufacture many of these viruses, if you will, the viruses which are manufactured are going to be manufactured using bacterium anyways. None of that is mentioned in this book. As a matter of fact, I don't believe this book even mentions the word phage. No mention of the word phage. So this book, Germs, is part of the slow roll of wiping out knowledge of bacteriophages. There's just viruses. All you need to know is there's viruses, and viruses can cause problem with people. It's wiping out the bacteriophage discussion. All right, so I'm going to restart this paragraph here. Sergei Popov then tried something more insidious. Rather than combining pathogens into unnatural hybrids or inserting foreign genes into microbes so as to expose new toxins, he looked for ways to trigger autoimmune responses. The aim was to trick the body's defenses into self-destruction as happens slowly in such diseases as lupus and rheumatoid arthritis, or more suddenly in cases of anaphylactic shock. In contrast, toxins seemed crude. He said, sometimes just small, very tiny quantities of foreign substances are enough to make the immune response quite devastating. And he disclosed an example. His team had inserted into virus genes that make protein fragments of myelin, the fatty material that forms sheaths around nerves. The Soviet researchers found that when an animal was infected with these hybrids, they could trigger an autoimmune response that resulted in brain damage. It was a potential breakthrough. In effect, the team had discovered a way to rapidly produce multiple sclerosis, the degenerative disease of the central nervous system in which the nerve tissue is destroyed throughout the body, resulting in gradual paralysis and death. In the mid-1980s, Sergei Popov was sent across the country to help scientists at the Obelinsk laboratories outside Moscow do some pioneering work, not with viruses, but with bacteria, which was that center's expertise. And they succeeded. In one case, Sergei Popov and his Obelinsk peers re-engineered Legionella, a troublesome but usually non-lethal germ that causes the kind of pneumonia known as Legionnaire's disease. The bug had been of little interest to germ warriors, but Sergei Popov said the Soviet tinkering had turned it into a killer. The trick again was the myelin. The scientists injected the modified Legionella carrying the myelin genes into guinea pigs, which at first came down with mild symptoms of pneumonia. After the Legionella microbe and its mild aftermath came and went, and all signs of infection were gone, the metabolic reactions to the myelin fragments began a second, more pronounced wave of sickness. The guinea pigs first suffered brain damage and paralysis and then died, with the mortality rate close to 100%. Sergei Popov said, but the symptoms were really unusual. The initial paralysis was of the rear legs, so half the animal was paralyzed and still active, and the front legs were struggling to move the dead hindquarters. In an unusual step, the director of Obelinsk came to visit the animal house to witness the grim results. It was easy for the scientists to conceive in rough outline how the designer germ would affect people. The infectious agent would be gone by the time it began its killing, leaving few or no traces for medical detectives trying to understand the root cause of the havoc. Popov and his colleagues had created not only a killer, but a very infectious one. With normal Legionella, many thousands of bacteria are required to sicken lab animals, but the recombinant Legionella was active with only a few cells. Military bioengineers don't need to start with a disease and make it worse. Instead, they could just make a new one, undoing what evolution and nature had produced over the ages. Around 1989 at Obelinsk, Sergei Popov presented findings to a group of more than 50 of biopreparat's leaders, senior scientists, and military officials. Without naming Sergei Popov, Ken Alabak recalled in the book Biohazard, again, that was published in 1999, what happened after the bioengineer made his presentation. It said, quote, "The room was absolutely silent. We all recognized the implications. A new class of weapons had been found. For the first time, we would be capable of producing weapons based on chemical substances produced naturally by the human body. They could damage the nervous system, alter moods, trigger psychological changes, and even kill," unquote. Sergei Popov said Ken Alabak's recounting of the experience in that book Biohazard, again 1999, was imprecise. The test used guinea pigs, not rabbits, as Ken Alabak had written, and involved the body's own reactions rather than poisonings by natural substances. Sergei Popov said his experiment was more subtle and menacing than what Ken Alabak had described in that book, Biohazard. According to Sergei Popov, the official reaction to such research was less enthusiastic than Ken Alabak suggested. The Soviet military officials who regularly visited Obelinsk and Vector to hear about the latest advances tended to be skeptical of the futuristic research. Very little produced by the genetic engineering programs was turned into weapons before the Soviet Union collapsed, he said. Recombinant Legionella was never made into munitions or deployed. An exception was plague, one of the oldest and most dangerous germ weapons. As Pachenik had described to Joshua Lederberg and others, the Soviets had worked hard to make the epidemic disease more lethal. Sergei Popov said the scientists at Obelinsk went further by splicing into plague bacteria the gene that makes the diphtheria toxin, which causes fever, chills, headache, nausea, and, if not treated, heart failure. The super plague with diphtheria toxin, Sergei Popov said, was highly virulent. He said, I know they tested recombinant strains in chambers of animals, primates, and that the results were very promising. Did the scientists of Obelinsk and Vector wrestle with the moral questions or ethical regrets? Sergei Popov, echoing Bill Patrick, said, we never doubted that we were doing the right thing. We tried to defend our country. Did they ever wonder if an enemy would be deterred by programs designed to be completely secret? Sergei Popov replied, the majority of the people around me, and I think myself, we always thought more about scientific issues than military applications. The work of designing new kinds of pathogens was a way to survive in that system, and I had no alternative. Sergei Popov said he believes the most devastating discoveries lie in the future. It's a very powerful technique, he said of biotechnology. If somebody wants to employ genetic engineering in creating weapons, the most exciting discoveries are still ahead. I think it opens, every day it opens, more and more possibilities to create something dangerous, to create a new kind of weapon. Sergei Popov said he still found the work of his former life attractive, a fascination that deeply troubled him. It was hard, he said, to stop imagining new ways to make designer pathogens. Reflection on his own impulses had led him to believe that biologists needed to be more vocal about the dangers of recombinant science. He said, it's a good time to express a certain concern. The whole technology becomes more and more available. It becomes easier and easier to create biological entities, and they could be quite dangerous. Days after the interview, Sergei Popov reported that American and Italian scientists had just published a paper on myelin peptides in the journal Nature Immunology that echoed the secret research he did for the Soviet Union. The scientists said they had accidentally triggered a mechanism that caused mice to self-destruct in a condition known as horror autotoxicity, which is a severe reaction in which the immune system tries to destroy its own tissues. Sergei Popov said the whole story is very similar to his Soviet research. Very similar. The futuristic military research by Sergei Popov, Ken Alabak, and other scientists presented America's biodefenders with a grim challenge. The vulnerability of soldiers and civilians to attack was growing. In what appeared to be a quiet biological arms race, much of which took place behind closed lab doors, offense was outpacing defense. Even before gene splicing became routine, an agent could be perfected in a few years, while a vaccine often took a decade to make and win approval. Narrator's note, so it sounds like what we need is a vaccine platform that can make the vaccine faster, and it sounds like we need a way to get around all this FDA approval stuff. More than a decade after the Gulf War, America's vaccine against botulinum remained experimental. Antibiotics were losing the war against pathogens, which were performing their own natural genetic engineering, mutating beyond the reach of the most powerful drugs. In the late 1990s, the Pentagon dramatically increased funding to find new ways of fighting infectious disease, pouring hundreds of millions of dollars for biodefense into the Defense Advanced Research Projects Agency, or DARPA, the little-known agency that had invented the Internet and stealth technology. DARPA, an arm of the Pentagon, had no laboratories or scientists of its own. Its managers wanted to underwrite the most audacious research they could find. The hope was to spur avenues of inquiry that industry had ignored or abandoned. It was understood from the beginning that the research was high risk, that many of the projects would fail. The first director of DARPA's Unconventional Countermeasures Program, Sean Jones, had his own clear vision of the future. A doctor and Navy commander who had been a member of the Navy's elite commando unit, the SEALs, Sean Jones had traveled the world on secret missions. He believed that defense against germ weapons required radical new approaches. The medical breakthroughs of the late 20th century had often been driven by profit. Pharmaceutical companies had made billions targeting individual diseases or maladies. There were blockbuster drugs to fight allergies, to slow baldness, to restore sexual prowess. Sean Jones wanted to go in the opposite direction, to search for breakthroughs that would provide widespread protection. One focus was multivalent vaccines that could prime the body's immune system to ward off a range of microbial threats. Someday, perhaps, researchers could come up with a single shot that conferred immunity against, say, plague, anthrax, and botulinum. Sean Jones was also fascinated by the potential of antiviral drugs. The viruses, which infiltrate and hide in human cells, had largely escaped medicine's weapons. But Jones believed new research might yield new ways to attack viral enemies like smallpox. A young colleague of Joshua Lederberg's, Sean Jones used the clout of the eminent scientist to recruit talent for his projects. Among the first researchers he signed up was Stan Cohen, the Stanford pioneer who, with Herb Boyer, had made the first recombinant breakthroughs in 1973. By 1998, the program had scientists working on 43 different projects. Stephen A. Johnston of the University of Texas Southwestern Medical Center in Dallas was typical. He had long nurtured blue sky ideas, and the National Institutes of Health, the main source of federal funding for biomedical researchers, had consistently rejected his proposals as unlikely to work and unsuitable for financial support. Backed by a DARPA grant, Stephen A. Johnston used a new biology to break a pathogen's genes into hundreds of different bits that he then injected into hundreds of mice. His next step was to infect the mice with the original pathogen. Typically, most fell to the onslaught, but a few exhibited resistance. In this way, Stephen Johnson discovered which DNA parts could be used to bolster the immune response and fight disease. He called the innovative method Expression Library Immunization, or ELI. He said, quote, "The basic idea is to let the immune system tell you what works," unquote. Peers hailed his research as surprising and elegant. Stephen A. Johnston's work represented a major advance for gene vaccination, a young field that promised to revolutionize the science of immunization. Traditional vaccines used weakened or killed versions of diseased organisms, or inactivated toxins or proteins from pathogens to give the body's immune system advance warning of infection and time to build up defenses. Gene vaccines were just bare DNA, often plasmids. When injected into the body and incorporated into cells, the genes expressed a limited set of the pathogen parts that were nonetheless sufficient to trigger the immune response. The approach was like a scalpel. Patients would be injected with precisely what needed to inoculate them against a disease. Though experimental, the method showed promise. It could eliminate the risk of infection associated with some live and weakened vaccines. It could also ease production and compliance with federal regulations, the complexities of which had stymied anthrax vaccines for so long. Gene vaccines were chemical and not biological. That cut the chance of contamination and spoilage. Finally, they were also highly stable. Unlike conventional vaccines that needed refrigeration, gene vaccines could be stored dry or in solution under many conditions and temperatures, making their distribution easier. Stephen Johnston's research was important because it sped up the identification of suitable DNA snippets, reducing the search time from a year or more down to months. And he proceeded to accelerate the process further, finding ways to mechanize it with tiny robots. His goal, which he called instant immunization, was to make a new vaccine in a day. If successful, this promised to help scientists react very quickly to attacks with designer bugs that no one had ever encountered before. Some of DARPA's most futuristic work was done by Maxygen, that's Maxygen, a small company in Redwood City, California, that Sean Jones visited just after its founding. It had pioneered a type of artificial evolution it called DNA shuffling. The concept was an elegant elaboration of Cohen and Boyer's discoveries, where the pioneers of gene splicing took a gene from one organism and moved it into another. Maxygen mixed up hundreds, even thousands of genes to produce a single new product. Nature works by a similar process of trial and error. Over millions of years, bugs mutate and a tiny number become better equipped to deal with their environment. Maxygen had found a way to fast forward the evolutionary process by recombining genes in hundreds, even thousands of new ways. One early project involved an enzyme used in detergents like Tide to dissolve grass stains, which researchers had been trying for years to improve. Maxygen's scientists shuffled thousands of genes in different combinations until they created a new genetic blueprint, one that had never before existed in nature, which involved 26 genes, each sliced from a different kind of bacteria. The result was a much more powerful enzyme that could be used in detergents. Sean Jones immediately saw the applications to biodefense. In 1998, DARPA gave Maxygen a $3.8 million contract to refine the enzyme further, making it strong enough to dissolve not only grass stains, but anthrax bacteria and other germs from hardened spores. Perhaps someday the military would have a detergent that could be sprayed over people and neutralize an anthrax attack. Another Maxygen contract for $7.7 million in 1999 focused on developing unusually strong gene vaccines that would stimulate the human body into super immunity against viral and bacterial invaders. The military also asked the company to develop aerosol-based vaccines that could be inhaled to safeguard people against a broad range of pathogens. A cloud of vaccine sprayed over many square miles was seen as potentially the simplest way to protect people and animals from epidemics. The main goal of the research was to shuffle the genetic material that made pathogen proteins and antigens, which spur the body to make productive antibodies. By tweaking the naturally occurring antigens of, say, anthrax, the company hoped to produce a more powerful immune response. Russell J. Howard, the president of Maxygen, said the initial results were encouraging and that it appeared to be possible to make vaccines that were not only more powerful but perhaps effective against several diseases at once. At first, many of the DARPA projects were criticized because they tended to be so radical. Work on modifying red blood cells to knock out toxins and microbes was ridiculed because no one had ever tried it before, and it was judged, for the near future at least, as merely intriguing. But other projects showed quick promise, often raising commercial interest. Shapiro at Stanford, who discovered an enzyme common to many bacteria, was widely praised for advances that promised antibiotics of broad effectiveness, and Maxygen, whose claims seem extravagant at first, was quickly proven right as rival companies rushed to exploit the shuffling technique. A measure of the program's success and Pentagon approval was DARPA's expanding budget for defense against biological weapons, which included not only work on medical treatments but research on such devices as advanced germ detectors. The annual budget went from $59 million in 1998 to $162 million in 2001 and was projected to hit $205 million by 2005. Over that time, the agency was to spend $1.2 billion, making it a new power in the world of biomedical research. However, the benefits of the DARPA-funded research for biological defense, if any, would be unclear for years or even decades. And Sean Jones acknowledged that some projects would surely be extraordinary failures, and that the value of others would not be known until they were rigorously tested on people. After all, a promising response in the petri dish or mouse was no guarantee of human benefit. That kind of evaluation required the slow, painstaking, carefully regulated process of clinical trials in which doctors and volunteers took on the responsibility of searching for unexpected side effects as well as proving safety and effectiveness. Gosh darn it, those trials and that FDA is always getting in the way of people just being protected against emerging diseases and terrorists. But Sean Jones and company saw the initiative as a good insurance policy, a cheap one given the stakes. In the last days of the Clinton administration, the Pentagon gingerly moved toward doing its own recombinant work on pathogens. The question that officials weighed for several years was whether to reproduce the vaccine-resistant strain of anthrax made by the Russian scientists. The goal was eminently practical. Pentagon officials needed to know whether the Michigan vaccine being administered to millions of American soldiers was effective against the genetically modified pathogens. The United States has been trying to obtain a sample of the strain since Russian scientists disclosed its existence in 1995 at a conference in Great Britain. American officials arranged generous grants for the institute at Obelisк, where the strain had been made. The Russians repeatedly promised to provide the germ to their American counterparts. But the arrangements always fell apart. Perhaps the problem was Russia's domestic politics. Relations between Moscow and Washington were rocky for much of the 1990s. Perhaps it was the legendary Russian bureaucracy. Or perhaps hardliners in the Soviet research establishment simply did not want to relinquish something the Americans wanted so badly. Whatever the reason, the superbug never made its way to an American lab, and so, in the late 1990s, intelligence officials began pushing for the United States to make its own version. The CIA believed the Germ Treaty authorized such research, but the agency officials were nonetheless reluctant to make the strain without specific intelligence that somebody, somewhere, was trying to turn such a pathogen into a biological weapon. The mere existence of the strain, CIA officials argued, would not be sufficient justification. The political implications of such recombinant research worried the Clinton administration. Among scientists, genetic manipulation had long since become routine. Still, intelligence officials hesitated. The project could produce tabloid headlines such as, U.S. makes killer superbug. In early year 2001, in the first months of the Bush administration, Pentagon officials decided that they would wait no longer for Russia to deliver the anthrax strain. The job of making the bug was turned over to a secretive DIA, Defense Intelligence Agency, program known as Project Jefferson. Established in early 1998 with a modest $2 million annual budget, the project drew its name from Thomas Jefferson's injunction, "Eternal vigilance is the price of liberty." Initially, the Jefferson Project studied the classical germ agents like the oldie moldies, as William Patrick III called them. One early effort assessed whether 8,000 to 10,000 spores was really needed to infect a person with anthrax. Much of the research was done by reviewing classified and openly published scientific literature. Other work was accomplished using computers that allowed scientists to make virtual pathogens and weapons. To make the genetically modified anthrax, the DIA turned to Battelle, its contractor in Columbus, which had also worked on Clear Vision, the CIA project. U.S. intelligence officials said that they understood the significance of the step they were contemplating, and that this was the only genetic manipulation the Pentagon had ever considered. To ensure compliance with the Germ Treaty's restrictions, the official said, the DIA would make only small quantities of the superbug, a gram or less. Officials said that with such amounts or such small amounts, the intent could only be viewed as defensive. Pentagon lawyers had reviewed and approved the secret project, which was done as part of Project Jefferson. Officials said that they hoped the military contractor would be able to make the novel form of anthrax and test it in animals by the end of the year. Other military scientists doubted that such an ambitious schedule would be met. While the preparatory work was underway in mid-2001, the actual creation of the recombinant anthrax had not yet begun. Experts said it would probably require a year or more to make the bug and determine whether it could defeat America's vaccine. Okay, narrator's note here. So we have a book called Germs, Judith Miller, that was published on September 7th or 9th of 2001. that talks extensively about the weaponized anthrax and all of the details of the anthrax vaccine, and of a DNA vaccine is going to solve all the problems. That refers to a large number of people that we've already covered, and for some reason no one else has ever covered. And it actually also specifically talking about the very specific strain of anthrax that was used in the anthrax letters. So it also covers the very specific strain that was used in the anthrax letters, and it talks about Battelle, and of course a CIA scientist, associated scientist, someone who also worked at the Defense Threat Reduction Agency, which this book gives a whole chapter to. His name was Daryl Galloway. Actually worked, I believe, directly or was somehow funded by this Project Jefferson at the Ohio State University, where he was testing a genetically modified anthrax on DNA anthrax vaccines. And it was even written, this book by Judith Miller, who was the first person to receive an anthrax letter, which was determined to be a hoax as part of Amerithrax. National Security Council officials in the Bush administration were told about the project soon, this is Project Jefferson, soon after taking office and viewed it sympathetically, a senior White House official said. No National Security Council or no NSC approval was required, he added. The Secretary of Defense had authority to press ahead on his own. The official said that the new administration saw the value of such work and planned to encourage more of it to help build germ defenses and protect American lives. It would be criminal, he said, to forgo such research. Same people that probably never said a peep about the drug epidemic in the United States of America, by the way. Ken Allebeck said he had no quarrel with the justifications advanced for secretly studying recombinant pathogens. But the niceties would not matter, he warned. If the secret research was eventually disclosed, many critics would have a different view. The United States would be accused of cheating on the germ treaty. The former physician turned biological warrior, who had spent much of his life working in a hidden weapons program, said that the work had to be done openly, if done at all. It can't be classified, Ken Allebeck said. If done secretly, you can't imagine the problems. The government's considered decision to take a first step into recombinant pathogens stood in sharp contrast to the frenetic, unregulated chaos of modern biology. Gene splicing in commercial labs was racing ahead and at times stumbling into dangerous new territory. As Sergei Popov had suggested, scientists in commercial labs were beginning to do openly and increasingly by happenstance what the Soviet military had done deliberately in secret. In February of 2001, Australian scientists had announced that they had inadvertently killed dozens of mice by making a virus that had crippled their immune system. At first, the scientists informed only the Australian government and military about the experiments, which were done in 1998 and 1999. But after intense debate, they decided to publicize their findings. Others needed to know of the potential danger in case such discoveries were turned against people. They said they had produced their inadvertent killer while trying to make their mice infertile as part of a pest control project. The agent they were experimenting with was a virus widely used in lab studies, mousepox, a cousin of the human smallpox virus. The scientists had inserted into the virus a mouse gene that controls the production of interleukin-4, a signaling molecule that helps the immune system fight off invaders. The goal was to make the immune system of a pregnant mouse so hypersensitive that she would reject her own eggs as foreign. The scientists did this by infecting the mice with mouse pox viruses that had been modified to carry the interleukin-4 genes. The result was a surplus production of this powerful immune system controller. But when the scientists infected the mice with their designer virus, the mice not only became infertile, they died. The scientists were surprised to find that even mice vaccinated against mousepox died. Birth control had become life control. Because people also have the interleukin-4 immune system gene, the team realized that creating a surplus of that substance in humans might kill them too. Worse, the Australians realized. A rogue state or terrorist group might be able to achieve this result with smallpox, the devastating human virus. Just as the super mousepox had defeated the mousepox vaccine, so might genetically enhanced smallpox defeat the human vaccine, the only existing protection should the disease reemerge. Ronald J. Jackson, who is the head of the research team, said, "We thought it was better that the information came out in case somebody constructed something more sinister. We felt we had a moral obligation." The news from Australia ricocheted through Washington, D.C., whose national security community had become increasingly concerned about the nation's vulnerability to the possible reemergence of smallpox as a terrorist threat. The Soviet Union had made smallpox by the ton. Moscow's alleged successes in manipulating pathogens, and smallpox in particular, had underscored a new dimension in the danger and helped prompt the Clinton administration to stockpile vaccine, not just for the military, but also for civilians. The effort was not going smoothly. The administration had been struggling for almost 3 years to produce new batches. Same problem they're going to have with the anthrax vaccine. By 2001, there were 2 separate vaccine programs. The military contract with one company called for 300,000 doses at a cost of $22 million. The civilian contract placed with another firm would provide 168 million doses for $343 million. While the White House had wanted the Pentagon and the Department of Health and Human Services to combine their orders to secure a lower price, the military had refused to go along. The cost difference was substantial, with the military initially paying about $70 per dose versus $2 per dose for the much larger civilian order. The Pentagon said its costs would fall as it placed more orders. To produce the civilian stockpile, Health and Human Services, HHS, hired the company run by Thomas Monath, the scientist who headed the CIA's panel of outside experts. Also, the man who Robert Malone worked for at Newlink Corporation in 2014 by the request of the Defense Threat Reduction Agency, the DTRA, for Robert Malone to go to Newlink and help be the businessman responsible for arranging the business deals between Newlink Corporation and Merck Corporation for the production of that Ebola vaccine. Thomas Monath is also deeply involved in One Health. And I also believe Metabiota. Now the White House had something new to worry about. If a state or terrorist group could develop a designer smallpox, say, laced with the interleukin-4 gene, then, in theory, neither the military nor the civilian vaccine might protect Americans in an epidemic. Perhaps it would take a futuristic antiviral drug to defeat the new threat. The interleukin-4 research in Australia, one government scientist said, prompted memos to officials on the National Security Council of the new Bush administration. The smallpox vaccine now being developed, the scientists warned, might be useless. Discussion ensued among federal officials about whether Project Jefferson should replicate the Australian research so that the United States could better assess the potential threat. In the end, the idea was dropped. There was no clear defensive rationale, no credible way to argue that a foreign threat existed that demanded such a scientific investigation. Australia was an ally, not a foe, and mousepox was not on the DIA or Defense Intelligence Agency's validated threat list. The problem was simply that science was advancing rapidly. It seemed possible that the troubling future envisioned by the scientists who invented the new biology more than a quarter century earlier was finally arriving. Deliberately or not, some researchers were coming up with new, more terrifying ways to kill. Matt Mieselson and Joshua Lederberg, the two scientists who had done as much as anyone to shape this new science, continued to differ on how to respond to the threat of germ weapons. Lederberg saw the modern trends as worrisome and advocated as many prudent defensive steps as possible. Mieselson took heart from the small number of germ attacks so far and believed that mankind's restraint could be reinforced with new global agreements. Joshua Lederberg tended to look for scientific solutions, assuming that the weapons would eventually be used. Meanwhile, Maselson advocated political approaches. But they did agree on much. Both men conceded that their hopes for the abolition of germ weapons had fallen short, and that a distressing number of their scientific colleagues, from those in the Soviet Union to Iraq to South Africa, had devoted their lives to producing pathogens that could kill in huge numbers. And they conceded that the defensive measures they separately championed had proven more complicated than they themselves had expected. Efforts to strengthen the 1972 Germ Treaty were failing, despite Maselson's tireless advocacy. And the military program of anthrax vaccinations had proven far more complicated, practically and politically, than Lederberg could have imagined. Both scientists worried that the Clinton administration had exaggerated the germ threat, doing more damage than good, at least in the short run. Lederberg faulted Bill Cohen's performance with the bag of sugar. Overstating the power of biological weapons could inspire terrorists to acquire them. Maselson wondered if America's new obsession with germ weapons might raise the political stock of scientists such as Wouter Basson, the leader of South Africa's apartheid germ program. People in other countries might see the sudden United States interest in germ weapons, the rumors of secret projects, and the backing away from negotiations to strengthen the Germ Treaty as a quiet return to an interest in offensive arms. As a hedge, they might embark on germ programs of their own. Both men agreed that the germ threat was real. To critics who claimed it was exaggerated, Lederberg replied with a question. Are there nuts in the world? Yeah, so we could be in trouble. Both scientists expressed doubts about the wisdom of wide vaccinations against future threats. For civilians, Lederberg said, his inclination was to put off the question of smallpox vaccinations, which had health risks and large financial costs. The focus should turn to developing antiviral drugs, few effective ones now existed, that in the future might make smallpox epidemics easier to control. His thinking was consistent with the federal plan, which was to stockpile new smallpox vaccine for civilians, but use it only to help contain epidemics if they broke out. Maselson's hope for the future was a global accord that would make the production and use of germ weapons a crime. The existing treaty applied to states and not individuals. A new accord based in criminal law might deter national leaders from seeking to develop germ weapons, discourage businesses from assisting them, and keep leading nations from looking the other way in the face of violations. He noted that the United States is already party to 7 treaties of this nature, including ones against hijacking airplanes, harming diplomats, and taking hostages. The new pact would simply give national courts jurisdiction over germ criminals from other countries. Lederberg said that making superbugs had turned out to be more difficult than first thought. Perhaps only 1% of the efforts were destined to succeed. But with enough time and investment in scientific resources, he noted, that rate of success, though low, was enough to produce new dangers. After all, Sergei Popov had created new superbugs, and even civilian labs, such as the one in Australia, were doing work that might be misused. Similarly, Joshua Lederberg was of two minds about ethnic weapons. Many experts dismissed them as science fiction, though Russia and South Africa had studied them. Lederberg noted that racial mixing and inherent ambiguity over definitions of ethnicity meant that no single genetic marker would give an attacker sufficient leverage. But in a half a century or so, he said, science might become powerful enough so that it could find a suitable combination of markers common to particular races. That might work as an ethnic weapon, Lederberg said, but why bother? There were much easier ways to use germ weapons against particular ethnic groups. Anthrax or other traditional killers would be quite effective in spreading death. Maselson also saw reassuring and alarming signs for the future. Foreign research on designer pathogens was often inept and illogical and done simply because ambitious scientists sought to please their military bosses. But while the topic of biological weapons had suffered much exaggeration, he said, the danger was serious for the long run. In the future, Maselson said, germs might be designed not only to kill, but to manipulate all life processes, cognition, development, reproduction, everything. They would, in short, bestow the power to change what it means to be human. He posed a troubling question. Might some group in the distant future use such powers to try to enslave others? Hitler, he noted, wanted to enslave the Poles and keep them as a nation of workers for Germany. Maselson said, are we really so sure that we're completely enlightened after 10,000 years of recorded history, even though Hitler was not that long ago? Are we now cured of such things? I don't know. And this is the end of Chapter 12, titled The Future, page 477 in this particular PDF. I think the PDF is a very small hardcover book. I also have a hardcover of the Germs book, which has very different formatting on the pages. The pages are much bigger. I thought that maybe the smaller pages here suggested this was a paperback, but I'm not sure. Anyways, for the PDF that you can download, it corresponds to page 477, and thus this is the end of episode 280.c, corresponding to chapter 12. The last chapter is chapter 13, or conclusions, in the book, which begins on the next page. That will be covered in episode 280.d. You can watch all of the videos for the 280 series by going to houstonic.live, clicking on playlists, and then clicking on Germs. There's a web page with a thumbnail picture for every single episode. The videos will play in order on a playlist on both Odyssey and on BitChute. If you are interested, this particular chapter was completely omitted and was quite a doozy. So I'm finishing my initial narration of this on Monday, May 19th, 2025. Thank you, guys. Hope to see you again. Hope you continue to listen to the series in the next episode, 280.d. Thank you. Take care. God bless.